Good morning all. Given a function, we're going to determine algebraically the intervals where the function is greater than 0. So let us just step back and look at this polynomial. Definitely it's a third degree polynomial. The zeros are of odd multiplicity, and the graph of the function between the zeros, it's either above the x-axis or below the x-axis, or greater than 0 or less than 0. Having said this, the best thing is, first of all, to find where are the zeros of this polynomial. So let us set this function to 0 and find the zeros. If fx is equal to 0, and then x plus 4 equals to 0, x intercept is negative 4, x plus 1 equals to 0, then the other x intercept is equal to negative 1, and finally, if x minus 5, we set it to 0, the third intercept is equal to 5. Which means, if we try to think logically, let us draw a line as if this is the x-axis, and let us just set those x-intercepts. If this is the 0, then negative 1 is over here, and the other x-intercept is negative 4, and the third one is x is equal to 5. Okay, these are our three zeros. This is my first 0, this is my second 0, and this is my third 0, or my three x-intercepts. Well, what to do to find out where the function, in which intervals the function is positive? Well, it's very easy. What about if we try to find out what would be the sign of the function before negative 4? Let's suppose it's negative 5. So what do? Let us just plug in negative 5 in this function and find the sign of the function at negative 5. And it would be negative 5 plus 4, negative 5 plus 1, and negative 5, negative 5. And the answer would be negative 1 times negative 4 times negative 10, and it's equal to negative 40. And negative 40 is negative, which means that just the function before negative 4 has a negative value. Okay? So in this interval, which means from negative infinity, when x is greater than negative infinity and less than negative 4, the function is less than 0. Okay, good. So that was my first interval before reaching negative 4. Okay, so if I draw a line, I'm going to erase over here. Let me erase this, and let me just show you the interval. So at the interval before negative 4, it is negative. It's going to come something like this, something like this, and definitely it's going to rise up. Let us find now the sign of the function between negative 4 and negative 1 algebraically. That's what it's being requested. So what do? With the same reason, with the same logic, let us plug in a number between negative 4 and negative 1. Any value. Let us just choose negative 3. Then the function, when x is negative 3, it's going to be negative 3 plus 4, negative 3 plus 1, and negative 3, negative 5. It's going to be equal 1 times negative 2 times negative 8. It's going to be equal to f negative 3 is going equal to positive 16, which is a positive value. It's a positive value, right? So there you go. So we can write out. We can write. I'm going to erase here, okay? So let me erase this so that I could go to the third interval. So the interval between -4 and -1 is going to be a positive, something like this, okay? Something. But it's going to be positive value. And here it's negative. And I can write that my interval x when it's greater than -4 and less than -1, my function, the function that we are trying to analyze, is going to be greater than 0 or above the x-axis. Okay, so let me just draw my other line over here. This is my interval before -4. This is my interval between -4 and -1. And let me just check my third interval where x is greater than -1 and less than 5. So let me do the same reasoning. Let me plug any number in the function between -1 and 5. I think, well, the easiest one is 0. You can choose 1, 2, 3, but 0 is okay. So let me just try to find out f0 equals to 0 plus 4, 0 plus 1, and 0 minus 5. And I will get 4 times 1 times -5, and it's equal to -20. And it has a negative value, -20, okay? So, my function between the intervals, let me write it down. Once again, I'm going to erase this one because I found that it's negative, and it's going to be something like this, okay? And I'm going to write down where my function x, where the domain x is greater than -1 and less than 5, my function is going to have a negative value, and the graph of the function is below the x-axis. So that's what's required. The question was, determine algebraically the intervals where fx is greater than 0. This is what we are looking at this time. If we were asked, find also the intervals where the function is negative, then we would say those two intervals. Okay, thank you so much, and see you soon in another presentation. Thanks.